Assalamualaikum warahmatullahi wabarakatuh. Hello everybody. Before I will explain about this material, I will introduce myself. My name is Diah Rahminati. Everybody call me Diah. I am college in Sriwijaya University from Chemical Engineering with name 0303 13 8 2025 422. Good day, learners. This is Easy Engineering. This time we are going to talk about kinematic. In physics, big topic of study is mechanics. This can be divided into two smaller topics about kinematics and dynamics. In this video, we will only focus about the kinematics and solving kinematic problems. To start with, let us define kinematic. Kinematic is a branch of mechanics which deals with equation that describes the motions of an object without external forces. Kinematic, which was developed largely by Galileo in the early 1600s, deals with equations that describe the motion of objects without reference to force of any kind. Various dynamics is the study of the effect that forces have on the motions. Motion of objects. These topics together comprise kinematics. We are going to focus on kinematics. Kinematics over the next few tutorials so that we can familiarize ourselves with the ways that simple equations will govern the motion of objects in one and two dimensions. These equations are revolutionary because from Aristotle until Galileo we thought that mathematics could only describe the perfect motions of defined colossal object and that the motion of object and earth was too indirect and interpretable to calculate. But we soon found that the same equation governing the motion of all objects, whether on earth or in space, is simple that on earth we must make approximations since there are the greater number of variables like frictions and x-movers that affect motions in various ways. The kinematic equations includes variables for displacements, velocity, accelerations, and time, and the context. Kinematic acceleration will always have a constant value, whether positive, negative, or zero, since we want to look at forces that cause acceleration to change over time. When you see subscribe or zero after velocity or displacement is indicated, initial condition which will have some implication depending on the problem we are looking at. Here are the three fundamental kinematic equations we will be using. The first one says that the velocity of one object at any time t is equal to the initial velocity plus the acceleration times the times. The next one says that the velocity an object with respect to a point of origin will be equal to its initial position plus the initial velocity times plus 1/2 the acceleration times x squared. Lastly, this one says that velocity squared is equal to the initial velocity squared plus twice the acceleration times the displacement. Other supplemental equations include that two, which are easily derived from simple definitions, which state that position is equal to average velocity times the times interval and that the average velocity. Say you get in your car to drive to the supermarket. While at rest, you place your foot on the gas and apply a constant acceleration of 2.5 meters per second squared. What will your velocity be after 10 seconds and how far will you have traveled in that time? We can use that two equations to find the answer. We just have to plug in what we know. For the velocity, we know that the initial velocity was zero because we were at rest. So we just multiply accelerations by time and we get 25 meters per second. That is the velocity of the car after 10 seconds. Maybe I think that's enough. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.